So our next speaker is going to be joining us by Zoom. So Dr. Sharon Wood is currently the provost at the University of Texas at Austin. So she received her bachelor's degree here at UVA in civil engineering and went on to get her PhD at University of Illinois at Urbana-Champaign. And she ended up joining the faculty there at Urbana-Champaign, and then was later recruited to UT Austin, where she became a department chair, dean of engineering, and ultimately provost. She's also an elected member of the National Academy of Engineering, which is one of the very top honors for engineers in our country. And so I'm very happy that Sharon's able to join us by Zoom, and really appreciate her still being willing to talk even while she's a bit under the weather. So I hope you'll enjoy her talk very much. But welcome, Sharon.
Thank you very much, Jennifer. And it's really nice to be with you today, even if it is virtual. I am very sorry that I wasn't able to travel to Charlottesville. Unfortunately, I had the flu this week and I'm still recovering from that. But when Dean West asked me to participate in this event, I had completely forgotten that I graduated from UVA 40 years ago. So I think this would have been a really special trip for me to be able to come and share with you. I do have some ideas that I'd like to share with you, though, and I'm calling this just reflecting over the past 40 years. So I look forward, even though it's a little more challenging with Zoom, I look forward to having some conversations with you about this. So I'm thinking back, as I mentioned, I graduated in 1982 from UVA. I hadn't really thought about that spring in quite a while. And I realized that I was probably doing exactly the same things you're doing right now, right? You're trying to finish up your projects and classes, get ready for final exams. I had an undergraduate thesis I was trying to finish, and then I also had to decide what I was going to do after graduation. And while I had a few job offers, the offer that I was most tied to, or I had summer jobs for 2 years in the oil and gas industry, but there was a global downturn. And so they were actually laying off permanent employees, and so they certainly weren't going to hire new people. And so that job didn't turn out. I remember I did get an offer where they told me that for the next 4 years, I would be designing anchor bolts for concrete pedestals. And I decided, no, I was not going to design anchor bolts for that long. And so I followed kind of in the footsteps of two of my mentors at UVA. Tom Baber and Furman Barton had both graduated from the University of Virginia. And so I graduated from the University of Illinois. And so I went to Urbana-Champaign with the expectation that I would spend a year there. I'd get a master's degree and I'd go out and be a consulting engineer. I think what really surprised me was how much I loved doing research. And that shaped my career. As Dean West mentioned, I then joined the faculty at the University of Illinois in January of '86. And 10 years later, I moved to the faculty at the University of Texas at Austin. So what I thought I wanted to share with you today, and I'll use my career as a little bit of the backdrop here, are just some themes that it's actually taken me a while to come to understand these and how important they are. But sharing essentially what I've learned over 40 years and how maybe they can impact you. Before I start on these themes, I just want to emphasize that this is an incredible time to be an engineer. There are all kinds of problems facing society where society is looking for engineers to solve them. These are, cybersecurity we hear about every day, sustainable energy systems and dealing with climate change, coming up with potable water. All of these are huge problems facing society, and engineers are going to be the ones who are going to be the innovators, the problem solvers, the creative thinkers, and the collaborators. And I think the other thing that's important to remember, is that many of the jobs that you might have in 20 years probably haven't even been envisioned yet. And I know we all hear the old stories, right, about everyone walking a mile uphill to school both ways and that sort of thing. But 40 years ago, the internet was not invented. And certainly things like cell phones were not around. So engineers have led this, and the pace of discovery is just continuing to increase. So the first thing that I wanted to just mention is really trust the fundamentals. We know that society is or technology is changing at this incredibly rapid pace. But the fundamentals that you are learning as an undergraduate student, you're learning about critical thinking skills, you're developing your problem solving skills, and you have a solid understanding of the basic principles of engineering. Those things are going to be the foundation of your career. And so you have to trust that when you graduate, you're going to have the background that allows you to go out and really have an impact on our society. I think the other thing is new technology is developed. So there's no way that you can learn today what you'll need throughout your career, but you make a commitment that you'll continue to learn. And I think that's also an exciting part about engineering is that you're always learning new things and you're always pushing new boundaries. And so I know that's something that I've thoroughly enjoyed during my career. My second idea was I wanted to share with you, I got a card of congratulations shortly after I became dean. And it said, what would you attempt to do if you knew you could not fail? And I'll be honest, this really struck me the wrong way, because as a structural engineer, failure is something that we learn from. And as I've thought about this more, I think it applies to your personal life as well as engineering, but let me at least just focus on the engineering part of this. So this is I-10, one of the busiest highways in the United States. This is in Northridge, California, which is right outside Los Angeles. And in 1997, an earthquake hit this area, and the most busiest highways in the United States were just shut down. In addition, I'm sorry, it was 1994, I apologize. In addition, some brand new buildings were actually collapsed. And so during my career, I did have the opportunity to observe earthquake damage in California, in Chile, in Turkey, and I really learned a lot from these failures. And so I want to change the idea of, don't worry about what failure, but my advice to you is throughout your career, take calculated risks. Take some risks where you're going to be outside your comfort zone. You're going to have to push yourself to do it. And it's not easy. But what I found is when I make the conscious effort to do this, this really has played dividends for me. So let me share with you an example. Shortly after I joined the Cockrell School of Engineering, so this would have been around 96 or 97, I was asked to just lead a brainstorming session at an international workshop. And I was specifically asked to come up with some really off-the-wall ideas just to keep the conversation going. Sometimes language barriers at these conferences tend to be a challenge. And so if you can get bogged down in silence. And so I was specifically asked to just throw some ideas out there and help us come up with some new things to think about. So for a few weeks, I spent almost all my time in the library looking at new sensor technologies. And I tried to envision how these technologies could be used to perhaps reduce the number of deaths in an earthquake, perhaps accelerate the post-earthquake recovery response, or just enhance the overall resilience of structural systems. I developed this set of icons that you see on the screen. And to be honest, I sketched them myself. They're really terrible. I'm not an artist. And I can't even remember what each one of them means. But one of the things that really struck my interest was in this same 1994 earthquake in Northridge, California, there had been a series of cracks that developed in what was considered to be the Cadillac of structural systems, of welded steel moment frames. And so I thought, well, let me see if I spent a couple weeks learning about this. Let me see if I can turn this into a research project and get some funding to continue that work. So I reached out to a faculty member in the Department of Electrical and Computer Engineering. I had never met him before in my life, but I saw he was working on sensors, and that was what I wanted to do. And I said, can we get together and talk, and maybe we'll submit a proposal? And he listened very patiently as I talked about all this. He came up with all these ideas of why what I was saying wasn't going to work. But then he threw out another idea. And that idea became the basis for an incredibly successful partnership that we had that lasted more than a decade. And when I think back about my career, that's probably what I'm most proud of. And so let me just share some of these details with you. If you've gone into any drugstore in the past 20 years, you've noticed they have some labels that are used to prevent shoplifting. And these are, we call them passive sensors. These really just, they'll sound an alarm when you walk out without paying for something. And so what we did is the idea of measuring cracks in the steel frames didn't work very well. But we moved to trying to identify when does corrosion occur in a reinforced concrete bridge slab. And there's a huge amount of damage that's caused every year due to corrosion. And so we were trying to identify, can we detect this early enough that you could do a small remedial change without having a large loss in the structural capacity of the bridge. So what's shown on the left was our first attempt to do this. The final attempt is shown over here on the right, much more robust. It actually worked much better. But the general idea was the same as that our RFID tag, was that it just was an LC circuit that would respond at a characteristic frequency. And we had an external reader that we could use. We could interrogate our sensors through the concrete. And because we had let me go back one, sorry, this sacrificial element right here, because we had this sacrificial element right here, this element was going to corrode before the surrounding reinforcement would corrode. And so it would give us an indication when the contaminants that cause corrosion have penetrated through the slab, and when it would be a good idea to remove the concrete cover, put a new topping slab on before structural damage occurs. So we call these our passive sensors. They could be embedded in a concrete slab, interrogated wirelessly. There were no batteries in these, so they could have an infinite life. And this, I'll be honest, was probably the most creative work that I ever did. And I think the reason I'm so proud of it is neither Dean, the professor in electrical or computer engineering, nor I could have done this alone. We had to work together to do it. And so I want to go back to that statement about imagine what you could do if you weren't worried about failing. Failing really is a part of engineering. And I was reminded of this just earlier this week when I was listening to the radio and they quoted Thomas Edison saying, "I haven't failed, I've just found 10,000 ways that won't work." What's really interesting is that I happened to visit Dow Chemical a couple years ago, and they're trying to identify particular chemical compounds for a given product that they want to develop. But they do this huge matrix approach where it's all computer driven, and they might do a series of maybe 100 different test formulations at a time. And then they pick the best one and keep moving on, but they save all those results. So the next time they're looking to develop another formulation, they can start from what they've learned in the past. And so I want to just emphasize that failures do occur in engineering, right? Things you're going to try don't work. You already know this. You've worked on projects where you had to iterate, you had to debug. That's all part of the learning process, and it's an incredibly important part of the learning process. So don't worry about that failure part. It really does make you a stronger engineer. The next thing I wanted to talk about was the importance of listening first. I think we often talk about leadership roles and how how important it is to be a visionary leader. But many times, being a leader means you need to listen to other people and make sure you understand their opinions before you actually make a decision. And so the example that I want to share with you is I spent a large portion of my career doing technical work through the American Concrete Institute. The most notable part of this work is developing building code standards. So this happens to be about a 600-page document, excuse me, that provides the guidelines for how every concrete building built in the United States is designed and constructed. And so there are about 40, 50 people who serve on this committee. There are some academics like me. There are some practicing structural engineers. There are some contractors. There are people who specialize in materials. Everyone has their own point of view. And the way that you make progress on this is through consensus. So if I have an idea of I want to add a new provision to the code, or I want to change something, I don't think it's meeting our current needs, I would write a proposal. This then gets reviewed in writing, and people submit written comments to it. And then I would have to respond to every single comment that was submitted and then revise my proposal. So this process is called the consensus process. It's painstakingly slow. We used to joke that we would be moving at glacial speeds. But what happens is everyone has an opinion, and everyone's opinion is listened to. And it's documented that if you have concerns about something, this proposal can't move forward until your concerns have been addressed. And so I can't tell you the number of times where I would develop a proposal thinking one thing, and then I'd read the comments that someone submitted, and I'd say, oh, wow, I didn't think about that. Or I understand their position, and now I need to think about things differently. So what I have found is that this sort of listening first and building consensus has been incredibly important to me as I've moved through academic leadership roles through my career. I started as a director of a laboratory where there were maybe 30 people, right? More than that, probably about 40, 50 people. But I knew everyone's name. And we were all doing experimental research related to structural engineering. Moving on to a department chair, I certainly knew all the faculty and staff, but I didn't know the names of all 800 undergrads and 200 graduate students. It just wasn't possible. By the time I became dean, now there are about 300 to 350 faculty members and over 8,000 grad students, undergrad and grad, and it just keeps getting bigger and bigger. So right now, technically there are over 50,000 students who report through various people to my office, and over 3,000 faculty members. So as you get further away from the individuals, you have to spend much more time listening more. And so I think that's what I've learned the most. I gained some of these skills through the American Concrete Institute, but certainly my role as an academic leader has really helped me understand the importance of listening. And as a leader, you don't necessarily have the loudest voice, but it's your role to build the consensus and to build collaboration. And so one of the things that I loved about being Dean of Engineering was because my role was to maximize the potential of the entire Cochrane School of Engineering. And so it's listening and partnering, making decisions based on what you hear, and then choosing the appropriate path. And so as I moved up in academic leadership roles, obviously the type of things I had to make decisions on, the impact of those decisions is broader. But I think the fundamental thing is still the same. You need to listen to the people who are living that experience and make sure that you are building consensus with them. The next thing I wanted to share with you was just the idea of paying it forward. I think, if you take it at any time in your life, if you sit back and reflect on how did you get there, what you'll realize is that there are so many people who contributed to your success. Maybe where you currently are, maybe you had a high school teacher who encouraged you to study engineering, or there was a practicing engineer who came to your high school and volunteered, or there was an organization that gave you a scholarship so that you could attend college. I think what I really want to encourage you to do, right, is you can't go back and thank everyone, but you can pay it forward by doing the same thing for other people. And so I wanted to share with you, every spring we have Introduce a Girl to Engineering Day in the Coppell School of Engineering. And this attracts about several thousand, this attracts several thousand young girls. Usually it's about K through 6 who come to this just to get excited about engineering. You'll notice all the students are wearing the green t-shirts, right? They're volunteering their time. We also would have companies come in to get students excited. And a couple of years ago, as I was walking around talking to the students, I met a volunteer who said that she had come as a 10-year-old girl to Girl Day. And that was her first experience learning anything about engineering. But it got her so excited that she was now a student at the University of Texas. And it was just a wonderful feeling, because when I was an undergraduate, the women who were my colleagues all had family members who were engineers. And so they had direct experience with engineering, over their life. But here we had someone who a volunteer or several volunteers had taken the time to donate, to spend their time to help educate them about engineering, and it had really impacted her. And so what I want to let you know is, as you volunteer, you are going to have a positive impact on many, many other people. You won't know what those impacts necessarily are, but I guarantee that you're going to impact others. The last thing I wanted to talk about was work-life balance. And it's because I think we hear about this strive for a balance, and it implies that work and life are in equilibrium. It's a place of stability. And so your career and your personal life are in perfect balance and harmony and all this. And I want to make sure you understand that, yes, we can strive for balance, but we have to acknowledge that we cannot control all aspects of our lives. There are going to be times when your personal life has to be a priority, and there are other times where your work is going to be a priority. So my recommendation for you is really to develop some strategies for stress management. Find things that allow you to enjoy what you're doing at work and in your life, and understand that you will be stressed at certain times. I think you probably already know that you can push yourself beyond normal limits for short periods of time. I think we all did that as we were cramming for exams, but that level of effort is not sustainable. So you have to find a way to manage the stress that builds up. The way that I do that is actually, for the past 30 years, I've been a cyclist. And I love being outside. I started riding in Champaign-Urbana, Illinois, where it is absolutely flat as a pancake. This happens to be a trip I made in 2013, where I rode my bike across the Alps. But this is how I find stress release. And then I also wanted to share with you that it's never too late to try something new. And so a few years ago, I just made the decision I was going to start running marathons. And it seems like an odd choice, but honestly, it gave me a new group of friends. It gave me a way to just get out of work for certain periods of time. And it's been very, very helpful for me. So again, I want to just go back to 40 years ago. What do I think the biggest change has been? And honestly, I think the fact is now you have incredible role models. You're meeting with them today. I'm showing you some pictures of people who participated in a similar event at the University of Texas at Austin about 4 years ago. So women who have been leaders in industry, they've been technical leaders, they've moved into they pursued all types of career opportunities. And I think what I learned the most from this is that there's no one path for success in engineering. There are so many different paths, and each one of you gets to define them. So as you look at pictures of people across campus, you are role models for the high school students who are thinking about careers, or the junior high kids. And so just women are everywhere in engineering today. And I find this to be really satisfying. And so I think that's the biggest change in the 40 years that I've seen. It's just the prevalence of women, the opportunity to have women as role models. And so I just want to add with a quotation from Maya Angelou about success. It's liking yourself, it's liking what you do, and liking how you do it. I have found that through engineering, and I have been incredibly thankful for all the many mentors who've helped me on this long path. So I'm going to stop now, and I will be happy to try to answer any questions that you might have.
I really enjoyed the talk. I specifically really enjoyed your emphasis on listening as a way of leading. And I try to listen a lot. I also am a loudmouth, so it's hard for me to listen that well. And as a result, I know that the corollary to listen to many voices is listen, but don't allow singular voices to monopolize, because the squeaky wheel is always the one that gets the grease. I try to spend a lot of my time encouraging people who might be quieter, people who might feel out of place or maybe lack a sense of belonging, to have their voice be heard. How can I do this better? How can we ensure that we're listening in a way that's not just an echo chamber?
You know, that's a really great question. One of the things that I tried to do was have forums where I could hear directly from people who maybe would not feel comfortable in speaking up in an open event, such as what's happening today. So as dean, every month I would go and have a study break with students, and they weren't sure what the dean did, but they could walk up to me and share with me the concerns that they had about the school. And then I could take it back to the group and say, hey, I heard this today. Something doesn't seem right here. Can we work on that? So I think I think you're right. There are always people, you know, that 10% of the people take 90% of your time. There are squeaky wheels. And that's just learning to kind of manage that. But I think there are other things you can do to try to make sure that you're engaging a broader community.